Zinc deficiency is a global malnutrition problem, with an estimated 1 out of 6 people at risk, which can cause growth deficiency and even death. Now, one of the most common causes of this is actually the soil. We know this because the areas where we see large-scale zinc deficiency are also the regions with low levels of zinc in soil. A major additional problem is when zinc is in a form that can't be absorbed by crops like wheat. So, if we can find a way to improve the plant availability of soil zinc, we might just be able to help solve a very serious problem. Our team at ETH Zurich decided to investigate 3 new approaches, all aimed at growing wheat with a higher zinc content. Green manure, that's the plant you grow after your main crop, leaving it on the field during the winter so that it dies off before the next main crop. Green manure brings in organic matter, improves soil structure and soil microbial activity. We grew wheat in a range of soils with different green manures to see what happens. At first, the results seem like they might be good news. Green manures made from clover improve the amount of zinc taken up by wheat in some situations, but in others, due to higher yields, the zinc content of wheat grains did not increase. What's more, there is the risk that plants also absorb more cadmium when fertilized with clover green manure. That's a serious problem because cadmium is an element that can cause cancer. That means it's not a ready solution. So, would we have any more luck with our second approach? We tried using bacteria called zinc solubilizing bacteria. Why would you be interested in bacteria? Well, these particular ones have the ability to take the zinc compounds which wheat can't absorb and turn them into a type which it can. Or at least, that's what happens when you do it in a petri dish or in a flask in the lab. But does it work in the soil? We took 8 strains which we inoculated into plant pots and then tried growing wheat. Unfortunately, the wheat inoculated with the zinc solubilizing bacteria did not absorb more zinc. It may be that future experiments can find a way to make this work, but for now it's not a viable solution. So, will our third approach fare any better? We went to Madhya Pradesh in India, where many farmers deal with soil that's low in zinc. At the same time, some farms here are using new or adapted farm management techniques, thanks to training from an organic farming cooperative called BioRe. This gives us the ability to compare it to farmers using more traditional methods. And there's good news. The results here were positive. It turns out farmers' membership of the cooperative led to 20% more zinc being present in their wheat, and no major reduction in the amount of grain being produced. While this result looks promising, we were not able to explain it. Appropriate farm management can lead to competitive yield and improved zinc concentrations in wheat grains. Now, while these management techniques won't be enough to solve the problem of zinc deficiency by themselves, they could make an important step along the road.